we were discussing the design guidelines for welded connection design. So I told you that if we want to design a weld, so for any design, so basic formula is the same. So what we require is that for how much force we need to design the welded connection. Or for example, if we want to design for a tension member or a compression member, then how much force will be transferred from a compression member to the gusset plate and vice versa. So that force is regarded as a FU that we will discuss it again today. And then I told you that if we know the strength of the welded material, then we want to balance the force with by the area of the welded material. And I have also explained that in the welding connection design, first of all, what we will do, we always fix the thickness of the weld. And if we want to determine the area, then only unknown quantity will be the length of the weld, because we are interested to determine the area of the weld required that will be safe, that will be required to transfer the force safely from one member to the other member. And I told you that we are actually designing the weld in a reverse order. Reverse order means that if we know the thickness of the weld and we assume the length of the weld equal to 1 millimeter. So if we know the strength of the weld of a unit weld means that whose area is equal to maybe 1, or whose thickness is known and the length is equal to 1. Then if we know that how much force can be transferred by a weld of unit length, then we can determine the total length of the weld to transfer the required force. So in that case, I told you that when we are designing the connection, so we may have two types of the possible failure. One failure is that actually the weld itself fail, or second option is that the weld will not fail, but the material along the length of the weld will broken. So it means that when the connection failure we discuss, we may have two type of the failure, either the failure of the weld material itself or the failure of the base metal. Base metal means that we are connecting two plates. So out of two plates, the thinner plate, which is whose thickness is lesser, will break because weld will be strong. So either the weld itself fail or the plate fail. Both type of the failure will be regarded as a weld failure. So we want to determine whether the plate will break first or the weld will break first. So accordingly, we will determine the strength of a unit weld. So last time I have explained that in welding, we are always having the shear stresses, for example, like this. So I told you that if we provide the weld, so this is a typical fillet weld. So thickness will be equal to TW along the width fraction. This thickness and this thickness will be same. And this is the length of the weld that we can consider equal to 1 millimeter or any required value. So actually, weld will always break from the point where the area is minimum. So this thickness is larger and this thickness is also larger. But the distance from this root to this outer surface is minimum. It means that the weld will always try to break along this minimum path. So which is the distance from the origin of the weld to the uh, theoretical face. So this distance is called effective throat or TE. So the area which will fail in here will be equal to this TE multiplied by length of the weld. So this was the capacity equation that we have discussed. So factored applied force should be equal to the capacity of the weld. So here the design force which must be transferred from weld to the connecting member, we can call it FU. Just like we are representing the tensile force as a TU, compressive force as a PU, bending moment as a MU. So similarly, we are writing is FU. FU is the design compressive or tensile force which must be transferred from the through the weld. So that is Fu, and the capacity of the weld can be computed as a phi Rn. So I told you that the capacity may be equal to, for example, here phi Rn. I can write down that phi Rn because I want to just repeat it so that the equation will be refreshed in your mind. So capacity will be equal to material strength F multiplied by the area of the weld, which may be in shear. So this capacity will be equal to the shear strength of the weld because the weld is subjected to shear stresses due to the tensile forces acting in the transfer from the weld to the gutter plate or other connecting member. So this will be the phi Rn. So phi Rn will be function of the two values. So here shear strength, if we are considering the weld, so shear strength we can assume that it is equal to 0.6 times of the normal strength because shear strength is not directly given. And then area of the weld may be equal to length of the weld multiplied by thickness of the weld, not thickness of the weld but effective throat because the area which will be in shear. So this was the basic equation that we have explained. So if you consider the length of the weld equal to 1, then that will be the capacity provided by the unit weld. So if we divide the total force by the capacity of a unit weld, we may compute the total length of weld. Anyhow, based upon this, I have explained how to compute the weld value. So shear strength, shear stresses or shear strength is equal to the force which is developed in the weld divided by area of the weld. So if we want to determine the R value will come in this side, and the shear strength will be multiplied with the area of the weld. So this first equation is based upon the weld strength. So if the weld will fail, so we need to consider the shear strength of the electrode that we are using, that we are representing as a tau E, and then area of the weld which is in shear. Tau value is assumed 60% of the normal strength. To convert the normal strength into shear strength, we multiply the normal strength by 60%. So Fe is the ultimate strength of the welding material or electrode. So area of the weld will be effective throat and into length of weld. Actually, effective throat we do not directly know. If the thickness of the weld is same, then I have explained that effective throat is equal to 0.707 of thickness of weld because I have already explained here. Because we know the thickness of the weld, this one, and if you draw a perpendicular from this origin to this middle point, so this angle will be 90 degrees, and this is the base, this is the perpendicular, and this is hypotenuse. So this effective throat TE divided by TW will be equal to sine 45. Sine 45 is 0.707. So in other words, effective throat will be equal to 0.707 of thickness of weld. So we are converting the effective throat in terms of thickness of weld. So we will have this answer: 0.6 Fe into 0.707 into thickness of weld into 1. So this is the weld value or strength of the welding material which is having a unit length. If weld is having 1 millimeter length, and if we know the thickness of the weld and we know the strength, the normal strength of the welding material, we can determine the strength or the force resisted by a welding material whose length is equal to 1. So this strength is based upon net weld. Net weld means the welding material. Second equation is that we are having the same equation. R will be equal to shear stress multiplied by area. So if weld is very strong, then the plate which is connecting the two connecting plate which are being connected by the weld, the plate which is thinner, that may be torn or that may be fail as a tear failure. So if the weld is strong, then plate may be torn. So a plate whose thickness will be lesser will always fail due to rupture, due to shear stresses. So here, if we are considering the weld strength based upon plate failure, then we need to consider the tau u value of the base metal, because plate is made of 830-60. So plate will be failed due to rupture. So we are considering the ultimate shear strength of the plate, which is equal to 60% of normal ultimate strength of the plate. So area of the plate will be equal to thickness of the plate TP1. Why I am writing TP1? Because TP1 is the thinner plate out of guzzled plate or the member which will have the lesser thickness, and the length of the plate will be equal to 1, because we want to consider the plate along the length of the weld. So I have also explained this last time, but I will show you again. So you can say that either the weld fail or this plate, this angle section will be fail from here to here along the length of the weld. So length we are considering 1, so thickness of the plate will be equal to thickness of TP1 or thickness of thinner plate. So based upon this, we have derived two equations. So again, I am explaining the weld value definition. It is the strength or load carrying capacity in kilonewton of a unit length of the weld, which is 1 millimeter, which is either depending upon the weld strength or member strength or base metal. So the force resisted by the strength provided by in a unit weld in kilonewton, which is either based upon the weld failure or base metal, whichever is lesser, that will be called as a weld value. So we are having two formula, phi r and w. Weld value based upon net weld, phi strength reduction factor 0.75. We are considering effective throat into area of the unit length into the weld shear strength. So phi value 0.75, 0.707 into thickness of the weld. This is the effective throat. Length of the weld is considered as a 1, and zero point 0.6 Fe is the shear strength of the weld. Similarly, weld value based upon the base metal, 0.75 strength reduction factor, zero point 0.6 Fu is the shear strength of the base metal, which is considered 60% of Fu, and area of net steel plate, that is equal to TP1 into 1. So always write TP1 means thinner plate. So I have written these expressions. So out of these two, whichever will be the lesser answer, that will be the weld value. Weld value means strength provided by a unit weld in kilonewton, which is either based upon net weld or base metal, whichever is lesser. So required length of the weld. So how much total length we need to determine. So RW is the strength provided by a unit weld. Gentlemen, please mute yourselves. Please do not open your mics. Amish Bashir, why your mic is not mute? Okay, here, let me rewrite this equation. So our equation will be same. I can say that Fu that is the total force which must be resisted by the weld, and that must be equal to Rw. So Rw and multiply by length of the weld. So let me explain. Rw is the strength of a weld whose length is equal to 1 millimeter. So Fu is the total force. So it means that if how much length is required, if total length is 5, then 5 multiplied by Rw mean that strength provided by a weld whose length is equal to 5 millimeter. If Fu value is 100 and Rw is 20, 20 mean that the strength provided by a unit weld is 20. Then how much length of the weld is required can be computed by this formula. The total length of the weld required will be equal to Fu, total compressive or tensile force, which must be transferred from one member to the other member through weld. So if we know the Fu, we know the what I can say that weld value. So we can determine how much length of the weld is required. So we are interested to determine Fu, and we are also interested to determine the weld value. So Fu, how to determine Fu and how to determine the Rw, that are the main important points. So Rw value is based upon thickness of the weld. So first of all, we need to fix the thickness of the weld. If we know the thickness of the weld and electrode strength and TP1, TP2, we can determine the weld value. And then we need to determine how much force is transferred from one member to the other member, Fu. If we know these two parameters, we can determine the length of the weld. And this length of the weld, then it can be provided in different segments. So you can say that this length of the weld we can provide in different intervals, and that interval will be L1. We can split up into different intervals. So what is you can provide, for example, the total length of the weld is coming out to be 100. You can provide a single weld of 100 millimeter, or you can provide a two weld of 50 millimeter. The total length must be equal to the total length of the weld. So we can provide this weld into different parts, L1, L2, into L3. That may be our length of the weld. Next question arises, how we may provide this weld, L1, L2, and L3. So just assume that this is the member, this is the angle section, and we are connecting with the gusset plate. This is the gusset plate at the end, just like I have shown you in some of the trusses. If we are having the double angle, so in between we will have the gusset plate. So it means that from the one member, once this is the one side, if I am looking to this side, the weld which is on the one side, it will be length of this weld will be L2. This weld which is provided on this thickness side, it will be L1, and this weld L3 that is provided along the depth, that will be our L3. So actually, if we are having a channel section, so for the channel section, for example, if you see this cross section, for a channel section, this centroidal axis will be in the center. So in that case, L1 and L2 will be same. But for angle section, our centroidal location, which is over here, I could sketch it. the central axis will be not in the center. So in that case, the both length of the weld L2 and L1, they may not be same, and they are depending upon the value that how much distance is this each weld is having from this centroidal axis. So in that case, we need to compute the weld length L1 and L2. So there are two options. For example, there are many ways we can provide this weld. I will discuss both options. Option is that this L1, let me correct this L1. So L1 will always be larger than L2. So L1 is always provided along the thickness section. Maybe this bottom and this length will be larger. For example, if the thickness is on the above side, then L1 will be on the other side. Size of the gusset plate is the function of the L1. So whatever is the length of the weld, gusset plate will be stand at the edge. So we provide the length of the weld from the edge of the angle to this side, and gusset plate will end or start at the edge. And L2 value, it can be provided anywhere along this space available, because gusset plate will have the same size on opposite side. So L1, for example, I have provided here at the edge. But if you want, you can also provide the L1 on this edge. So L1 may be, sorry, L2. So this L2, it can be provided anywhere, maybe on this edge, or maybe at this edge, or maybe in center. But this is a good option, because always provide the L2 on this edge. Because if you are providing on this, then unconnected portion of the angle section will be lesser. If you are providing L2 here, then this much portion of the angle section is also unconnected. So L1 will be the full length, because gusset plate size is based upon L1. And L2, which is lesser than L1, it may be provided anywhere, but this is the appropriate option. So if we are having double angle, so we also need to provide the weld on the other side. So this is the cross section of the weld. So fillet weld is provided. L1 is on the thickness side, L2 on the other side, and sometimes we also provide L3, and sometimes L3 may not be required. L3 is along this face. Along this face means that if you want me to show here, so from the cross section, so L1, L3 will be somewhere here. So this will be the L3 if you are providing this. This will also be there. So first of all, we will always try to provide L1 and L2. So sometimes we also require L3. We will study the case in which case we are requiring the L3. So this is case. So we compute the total length of the weld from here, and then this total length of the weld can be split up into two parts or maybe in three parts depending upon the location. So again, I have told you, if you are using the channel section, then L2 and L1 will be same, because both L2 and L1, they are situated at the same distance from the neutral axis. But if axis is not in the center of the depth, then in that case, just to balance the movement produced by both forces which are developed in L1 and L2, that may be different, and we need to compute their length accordingly. So we will see the derivation in our next slide. So we may assume that Fu is the maybe any force, which may be tensile or compressive. That is not the force of the member. That Fu is the design weld force for which we need to design the length of the weld L1, L2, and L3. So here we are considering this Fu as a tensile force and which is passing through the center line of this angle section. So here I am considering only a single angle which is connected with this gusset plate. So the thickness of this angle section may be TP1 and thickness of this gusset plate may be TP2. So let's suppose we are providing this weld into three segment L1, L2 and L3. So if this force is acting in this side, so the force which is resisted by L2, L3 and L1, they are acting on the opposite direction. For example, P1 is the force resisted by, or the component of the force resisted by L1 to balance Fu, and P3 is the resisting force which is produced in L3 to balance Fu, and P2 is the force or the that is resisted by the weld of length L2. Total depth of this angle section is D. D is the total depth, and we can say that Y, sorry, Y is the distance of the centroidal axis from this bottom. So this is the Y distance from this bottom face to the centroidal axis. That is the Y. So Y is the centroidal location. And if this distance is the Y and total depth is D, then the distance from the centroidal axis to the top side will be D minus Y, just like I have shown here. So this distance is the Y and this distance is D minus Y. So Y value for angle section you can take from this section properties table, and the depth of this angle section will be equal to the depth of this longer leg. But anyhow, this equation I have already written. Total length of the weld is equal to Fu divided by Rw. Rw is the strength provided by a unit weld or weld value. So length of the weld can be written as a L1 plus L2 into L3. If we know the weld value, so what is the definition of the weld value? Force resisted by a weld whose length equal to 1. If the resistance offered by a unit weld is known, if we are multiplying the by the total length of the weld, then that will be the total resistance offered by the L1 weld, which is P1. P1 is the force resisted by L1 weld because L1 is being multiplied by Rw weld value. Weld value, if it means that if the L1 is equal to 1 millimeter, then force resisted by that weld is equal to maybe Rw or maybe 1 kilonewton. If we are multiplying the weld value with the total length of the weld, we will have the total force resisted by the L1 weld. So P1 can be considered as a Rw into L1, P2 will be equal to Rw into L2, and P3 is equal to Rw into L3. So Rw value is constant that we can determine depending upon the thickness of the weld and type of the electrode used. Similarly, U will be equal to Rw into total length of the weld. We know the this forces, Fu force is known, P2, P3 and P1 is known. So we can determine the relationship for the length L1 and L2, L3. by taking the equilibrium equation. So by equilibrium equation, PFU, if you are taking summation Fx is equal to 0, Fu must be equal to P1, P2 plus P3. And we can take the moment at any point V equal to 0. So when we are taking the moment, we can consider the thickness of L2 and L1 as a 0 or negligible. So here, taking the moment about point A and equating it to 0. We are taking the moment at point A equal to 0. If we take the moment of all the forces at point A, so P1 is passing through point A, it will not produce any moment. So P2, it is producing the moment about point A in counterclockwise direction. So that will be P3, and this moment arm will be D by 2, because this P3 force is acting in the center of this L3. So L3 is equal to D by 2, total depth. Or you can simply take the P3 equal to L by L3 by 2. And then you can take the moment of this force P2 about this point A will be equal to P2, and moment arm will be equal to total depth. And this moment is also in counterclockwise direction, and that moment must be equal to the moment produced by Fu. Or you can write the moment produced by Fu about point A will be equal to Fu multiplied by distance from this centroidal axis to this point A, which is equal to y. So clockwise movement must be equal to the counterclockwise movement. Or if these two movements are positive, movement produced by P2, P3, then movement produced by Fu about point A will be negative. So you will have this equation. So P2 moment arm is D, and for P3 moment arm is D by 2. So we can substitute the value, because here uh, you can write down Rw also. This is not writing. Rw. So he is not writing the bracket at the moment, but I will correct it again. So let me write down the Rw with everywhere. So why? Because P2, because P2 is equal to Rw into L2, P3 is also equal to Rw into L3, and Fu is also equal to Rw into length of the weld. So that's why I have written. So this Pu is not Pu, that will be Fu. So Rw is constant, can be taken as a common from the entire equation. So this equation will become L2 into D plus L3 into D by 2 and length of the weld into Y. So in this equation, actually we know the L3 value. Why? Because L3 is equal to total depth. So only unknown will be L2. L2. So simplifying this equation in terms of L2. So L2 is equal to total length of the weld multiplied by Y. Y distance we can take from section properties table divided by D value minus D by 3, D by 2 or L3 by 2. So in this way we can determine the length of weld L2. So if we know the length of the weld L2, so from here L1 value you can determine by another way. So L1 can be length of the weld. So L1 will be equal to the weld minus and minus L3. So this is how you can determine the L1 because we have our length of the weld totally is equal to summation of all length of the weld. If you have determined L2 already known, so only unknown will be the L1. So L1 can be determined as a lead minus L2 minus L3. So L2 can be determined by this formula. And again, if you want to drive the you need to take the moment at point B equal to 0. If you are taking the moment at point B equal to 0, moment produced by P3 multiplied by D by 2 or force P1 into L3 or D. And the moment produced by Fu force about this point B will be equal to, and the moment arm will be D minus Y. So you will have this expression. So in fact, the function of Y over D ratio of the length of the weld and L1 is equal to D minus Y over D ratio of the length of the weld. So if we do not provide L3, if L3 equal to 0, if we are not providing the length, this 3 weld L3, because we do not want to provide a length L3, because this weld will be having less effective. The most effective weld will be L1 or L2. So if equal to 0, then L2 is simply equal to length of the bundle. And similarly, L1 will be equal to length of the weld into D minus Y over D. So first of all, we will only compute the L2 assuming L3 equal to 0 and L1 by assuming L3 equal to 0. If the strength provided by L2 and L1 is less than the Fu, then we'll provide L3 again and we will compute the length L2 and L1. So this is very important case, three cases that you need to understand. If M is greater than L2, if L1 is greater than L2 and L3 is first selected equal to 0, then following procedure may be used to check the length for minimum and maximum limits. So number one case is that if I told you that we are having and maximum range of the length of the weld. So ASC says that length of the weld L1 should not be more than LW maximum. And LW maximum is 30 times the thickness of the weld or 305. Let me show you again. So we have discussed already. So maximum length of the weld, single weld, should not be more than 30 times of thickness of weld. If L1 is coming out to be 30 times of thickness of the weld, then we will provide the L3 and then revise the L1 and 30 times of thickness of the weld, then we may provide the intermittent weld. We may break and we provide the intermittent weld with a clear spacing of 100 to 150 millimeters. So there are three or alternative option that we may have. So first we will provide the L3 equal to 0 and we will compute the L2 and L1. This is for the case of the angle section only because L1 is larger than L2 in case of angle section. For channel section, L1 and L2 will be same. So if L1 is less than LW maximum and L1 is also more than LW minimum, which is 4 times of thickness of weld, then we will use the L1 without any modification. That will be final. But if L1 is less than LW minimum, for example, LW minimum is 4 times thickness of the weld or 38 millimeters. If LW minimum, for example, this answer is 38 millimeter, but L1 required is maybe 10 millimeter. We do not provide the length of the weld less than LW minimum. In that case, you will increase the L1 to the LW minimum. So we will provide the minimum weld. But the third case is very interesting. If L1 is more than LW maximum, then in that case we are having three options. So what are the first options? We may provide L3 equal to the length of the end face of the member and revise L1 and L2. That is most common solution. So L3 will be equal to total depth of the angle section. If 3, if L1 is still larger, then you know that we can increase in that case the thickness of the weld. So thickness of the weld, if you are using as a 6 millimeter, so we may use the thickness of the weld as a 7 or 8 millimeter. Why? Because here I will explain. Because total length of the weld is the function of the weld value. So weld value is the function of thickness of the weld. So it means that we can reduce the length of weld by increasing the thickness of the weld. So if you are increasing the thickness of the weld, so weld value will also be increased. Here, thickness or TP1. So more will be the thickness of the weld, more will be the weld value. If weld value will be more, so we will have the lesser length of the weld required. If total length of the weld will be less, so it means that L1 will also reduce. But again, we have studied that the maximum thickness of the weld that you are providing is that we can provide is the T optimum, which is 8 millimeter. We cannot increase the thickness of the weld beyond 8 millimeter. If you are already using the thickness of the weld as a 8 millimeter, then the other option you are having that increase the electric here. Because if you cannot increase the thickness of the weld, then you can increase the electrode value because of the electrode. If the weld value, if you cannot change also the electrode value or the value, the other or the last option is that if L1 is still more than LW maximum, and LW maximum is, for example, 200, and L1 is coming out to be 300. So you may divide the L1 into two segments. Each segment will be 150 and clear gap may be 100 millimeter can be kept. So we can use the intermittent weld. So these are some options. So in the meantime, if someone is, so he can ask me the question. So definitely give you the break after 15 minutes, not at the moment. So before the break, if someone is having the question, so he is most welcome to ask. So let me ask the question to some student. So if anyone know the answer, just raise the hand. On which two parameter the weld value is depending upon? Anyone who knows the answer, please raise the hand. What is the Hamza? Okay, anybody else? What is the weld value? No question. I will rephrase it and I will ask another question. Then what are the possible? There are two possible failure in welded. Okay, very good. It's mean that many students they know the answer. So, but I would like to ask the student who is maybe raised the hand first time. Okay, Rakib, please, would you like to answer? What are the two distinctive or two type of the failure which are possible? Yes, Rakib,
सर
please.
एक फेलियर होता है
हाँ जी, and second.
वेल्ड और जो दूसरा है वो मतलब जो मेंबर की अलोंग लेंथ है वो मेंबर फेल हो सकता है
कौन सा which member will fail? Which is thinner or thicker?
थिनर थिनर
Thinner. Okay, good, good. Either the thinner plate may be torn along the weld or the weld itself may fail. Okay, now another question. What type of the stresses are acting in welded connection? Shear, compressive, or tensile? Raise the hand. Okay, Ahrima, I guess. Please, would
Yes, sir.
you like
Shear
to?
stresses.
Okay, good. Shear stresses. Okay, now my third question that I am repeating. What is the weld value and on which two parameters it is depending upon? And other than Bilal, raise the hand. Okay, Bilal Mirza, you answer. Bilal, Bilal Mirza, would you like to answer? Not working. Yes, Hamza Niaz, please, would you respond? Hamza, हाँ जी बताएं. Okay, very good, very good, very good. Okay, until now, it means that we can compute the length of the weld if we know the weld value and FU. You understand me? But I haven't discussed what is the FU. Maybe at the moment you might be thinking that FU is a simple compressive force or tensile force. No, this is not that one. This is to be computed, and now we will see that what will be the FU value. So definitely I will give you the break after 10 minutes, but before that we may discuss maybe a couple of the points for the design procedure of the weld. So in the design procedure, just whenever I explain, always think of this equation. We require length of the weld, and to compute the length of the weld, we need FU value and we need the weld value. So weld value, first of all, for the weld value, we need to determine the fix the thickness of the weld. And thickness of the weld is based upon TP1 and TP2. So that's length. So if we fix the thickness of the weld, we select the type of the electrode, we know the thickness of the two plates which are being connected, and then based upon we can determine the RW. And if we know the FU value, then we can determine the length of weld. And if we know the length of weld, we can compute L1, L2, and L3 accordingly. But the next question arises, what is the FU? That is the design weld force, which must be transferred from member to the weld. So this FU is the function of the member, type of the member. So now we are going to discuss this parameter. Write all known data included selected member section, factored member forces. So factored member force, what is the compressive and tensile force in the member that we are going to connect with the gusset plate or with another member. In case of lap joint, the amount of lap shall be 5 times the thickness of the thinner part, but not less than 50 millimeter. So I will explain that is not directly related at a moment. So actually we are placing this angle plate on this gusset plate. So there is an overlap. So he says that minimum overlap should be 5 times the thickness of the plate, thinner plate. It means that this overlap that we are providing with the gusset plate to this weld, this the angle, that should be 5 times of the thickness of the plate. Much lap, overlap. Decide the gusset plate thickness such as it should be same. So actually, gusset plate thickness. Gusset plate is the plate. So let me show you the gusset plate also, just to refresh the concept. So what is the gusset plate? Okay, here you will see this is the plate which is connecting the different member of trusses. So truss member, they are not directly connected with each other. So this is the diagonal member, and this diagonal member is connected with the gusset plate, and then this gusset plate is connected with the other vertical member or the bottom chord. So here one gusset plate is connected with 3 members, and here one gusset plate is connecting 1, 2, 3, 4, 5 members, and here only maybe 3 members. So if we are discussing the interior, so we need to design this connection. This is a riveted connection separately. We design the weld separately with this gusset plate and with this member, and this welded or riveted will separately will be designed for this member and this gusset plate. So the size of this gusset plate, actually this is depending upon width is equal to width of this section, and the thickness is the largest thickness of any member available in this section. If in our truss, whatever is the heaviest member, what is the largest thickness of the member, or largest thickness used in any member of the truss, that would be the thickness of the gusset plate, and that should not be less than 10 millimeter. How sometimes I may ask very small quiz question in the quizzes or maybe in paper, how we decide the size of the gusset plate. So here is the answer. So thickness of the gusset plate is same throughout the truss. So if the thickness of the gusset plate is 10 mm, so in the entire truss, the thickness of the gusset plate will be kept 10 millimeter. So how we decide this? We see that what is the largest thickness of any section available in our truss. So the thickness of the gusset plate should either be equal to or more than that heaviest member. And we keep the thickness of the gusset plate same throughout the truss. So avoid the error. Avoid the error mean that maybe sometime we may have error at one joint. We require the gusset plate thickness maybe 10, and maybe on another joint we may require 16. And by mistake, if we have switched their thicknesses, so that may cause the connection failure. Just to avoid this issue or the human error, we select the largest thickness of the gusset plate in the truss, and we provide the same thickness in our entire trust. So comparable to the greatest thickness of the member joining with it. Whatever is the greatest thickness of any member available in our trust, that would be the thickness of gutter plate. If the largest thickness in our truss is 5 millimeter, then we, even though we cannot select the thickness of the gutter plate less than 6 millimeter, minimum thickness should be 6 mm. And normally we keep the minimum thickness equal to 10 mm. So preferable minimum thickness is 10 mm. For example, if the largest thickness of any member in truss is 5 millimeter, even though in that case we provide the gutter plate as 10 mm. Size and the shape of the gutter plate are decided during drying. So in drying phase mean that I have already explained, but when we are solving the question, I will explain. So first of all, we design the weld. After designing the weld, we provide the weld L1 and L2. So gutter plate will start at the edge of length L1, and then we provide a certain angle. So this is provided at certain angle, which is called the flare angle. And the angle of the gutter plate, so edge will start from the edge of this weld L1, and we increase the weld by a certain value, and this angle is more than 16 point, sorry, 22.5, which is called the flare angle. I will discuss it again when we are sketching the weld after designing the weld. In case of member with stress reversal, so you might have table of forces. So how to compute the design force? If we are having a stress reversal member, then in that case we design the weld for largest force out of the compressive force or tensile force. In case of member with reversal of forces, only design for greater magnitude forces without being multiplied with any factor. If tensile forces are larger, Fu will be equal to tensile forces. If the compressive forces are larger, then we will design for the compressive force. So find out the load carrying capacity of the member that we are designing. Phi C tensile capacity and compressive capacity also. If it is a stress reversal member, then we determine both phi TTN and phi CPN, compressive capacity and tensile capacity. Or if it is a compression member, we will only determine the compressive capacity. If it is the tensile member, then we will only design for the tensile capacity. Then here it is very important. What will be Fu? Design factored force Fu for a member discontinued. Discontinued means that for any diagonal member, that it's seen that I may write here. Let me copy some equation from somewhere. So this is very important to understand. I will repeat it many times. Fu value is equal to lesser out of following. Phi C or Pu. And number two, phi c Tn will be phi t and here and 0.5 here. What? That is not coming. What happened? Lesser out of forming. So FU is actually, if it is a compression member, then PU and 50% of the compressive capacity in compression, phi CPM. And if we are having tension member, then Fu is lesser out of Tu. Tu is the total factored tensile force which is acting in the member, or 50% capacity of the tension member, whichever is larger. Okay, what is the reason? If we Tu and Pu is larger, then why we are taking the 50% capacity criteria as well? So I have explained that sometimes we are having zero force member. So zero force member mean that are not to any TU or PU, compressive force or tensile force. Those zero force members, they are designed based upon slenderness ratio. So in that case, their 50% capacity can be taken as a FU value. Or sometimes we know that if we are designing a tension member for a 100 kilonewton force, after designing the capacity may be equal to 150. So capacity may be more. So TU is the larger value out of compressive or tensile force and their respective 50% capacity. This is any discontinuous member. Discontinuous member mean that the diagonal member or maybe any top chord member and bottom chord member, which is the individual or separate member. And next is, this is the last slide before the break I will discuss. If the member is double angle section, then we divide the FU by 2, and then whatever is the weld we compute, we provide on the both sides. This perfect example is over here. For example, if we want to design the weld for double angle, it means that total force is FU is resisted by 2 angle section. Then we divide the FU by 2 and we compute the weld only for the one phase, and the same weld will be provided on the other side. For a single angle or single section with the bezel plate, Fu will be total Fu. For double angle section, Fu will be divided by 2 because total force is resisted by the weld on the both faces. And then we already know the type of the section, angle section designation, because you have already designed the tension member or compression member. From the section properties table, you can check what is the D value and Y value. We know the thickness of the angle section or the any W section or any section, channel section. We know the thickness of the weld. Depending upon the TP1, TP2, TP1, TP2 is the thickness of the thinner plate, which will be our section, and TP2 will be thickness of the bezel plate. We may compute the decided thickness of the weld. I have explained we can compute three values: TW minimum, TW maximum, and T optimum. The middle value will be our the thickness of the weld. Then we decide the type of the electrode. We determine the weld value, which is either based on weld strength or the strength of the base metal. And if we know the FU or W value, then we compute the total length of the weld. And we, after compute of the weld, we compute L1 and L2. This is will be L2. This value is the L2 and this value is L1. By the L3 equal to 0. First, if L1 is less than LW minimum, LW maximum, then these lengths are final. If L1 is more than maximum, we provide L3 and we recompute the answer. So I will stop here. I will take a break, and break will be of there is a time is 2:18. Break will be of 20 minutes because I need to pray. So I will resume at 2:40. So I will resume the lecture at 2:40. So because I need to pray Zohar, so I would like to take break. So if someone will have the question, so he can ask me after the break. Okay, great. Okay, Bismillah Rahman Rahim. Okay, before the break, we were discussing how to design the weld or and how to design the to compute the forces FU. So we were here. So I told you that first of all, what we do, we decide regarding the thickness of the weld, and the thickness of the weld is depending upon the TW minimum, TW maximum, and T optimum. And we arrange these three values in ascending and descending order, and the middle one value is fixed as a thickness of the weld. And then we decide the type of the electrode, and depending upon the type of the electrode and thickness of the weld, we compute the weld value, which is the strength provided by a unit weld, which is either based upon the weld strength or base metal, whichever is lesser, by these two expressions. And then we compute the total length of the weld, which is equal to Fu divided by weld value. And after computing the length of the weld, we determine L1 and L2 weld. If it is the channel section, then L1 and L2 will be same. If we are having the angle section, then we need to compute the L1 and L2 by either of this formula. So first of all, you may either compute L1 or L2 by using these given expressions. And first of all, we assume L3 equal to 0. And if you know the L2, L1 may be equal to length of the weld minus L2 and vice versa. And after computing L2 and L1, we compare these weld value with LW minimum and LW maximum. LW maximum is 30 times of thickness of the weld and LW minimum is 4 times thickness of the weld. If L2 and L1, these values are less than LW minimum, so we provide both value equal to LW minimum. But if length L1 is more than LW maximum, then we revise the L1 and L2 by considering the L3. And L3 value is directly known, given. Why? Because L3 is provided on the entire face, and L3 will always be equal to D value. And in that case, you don't need to revise the L1 and L2 value. You can just subtract the L3 by 2 or D by 2 from previously computed L2 and L1 value. So from previously computed L2, L2 and L1 value, if you are subtracting L3 by 2 or D by 2, you will have the modified L2 and L1 value. And if L1 is still more than LW maximum, then we have already discussed these three options. We can either increase the thickness of the weld, we may use higher electrodes. If again it is more, then we can go for intermittent weld. So check length L1 and L2 for minimum and maximum limit. Decide the side weld length L3 if L1 is more than LW maximum. And assuming that L1 is greater length, first check it against the limiting values I have already explained. If L1 is more than LW minimum and less than LW maximum, it is okay. No need to provide L3. If L1 is less than LW minimum, so we will provide the L1 equal to the LW minimum. And if L1 is more than LW maximum, then we provide the L3 equal to D, and L1 and L2 will be previous values minus D by 2. So whatever the L1, L2 value you have computed, just subtract D by 2 from these values, just like I have explained. Because these are the factor L2 without L3. And this is the value of L1 without L3. So if you see the expression that we have already derived, so if you are subtracting L2 which is previously computed and you subtract the value of L3 by 2 or D by 2, you will have the modified L2 and L1 value if you are using L3. Or you can compute by again by using this entire formula. If L1 is still larger than LW maximum, then we can increase thickness of the weld or we can go for the intermittent weld. We will solve one example related with this case. Similar check is also applied for L2. So sometimes if we are having the tension member, so you know that in design of tension member, you have assumed shear lag factor, which is referred as a joint efficiency factor. And this equation to compute the efficiency factor is 1 minus x bar over L. And x bar is the distance from the centroid of the section to the edge or from the web. For example, x bar in our this case is the distance from the centroid of this section to this edge of this gutter plate. So this will be our x bar. So x bar is the distance. Maybe I would like to sketch. So you can say that this line is the location of centroid, and distance from here to this edge of the gutter plate, that may be our x bar value. So you can say that this is the our. I don't know why it is not writing it, but anyhow, the value from here to here is the x bar, distance from the centroid of the angle section to the edge of the plate. And L is the length of the connection. So length of the connection is the length of largest weld, which is always equal to L1. So L1 is the length of the weld along the length of the member, or the largest length of the weld out of L1 and L2. So this will always be L1. It will not be the combined length of L1 or L2. So length of connection is the length of largest weld L1. So length of L1 is also checked against the efficiency factor. And how you can compute this? By using this formula. For example, if you need the minimum efficiency 90% in tension member, so U value will be zero point 0.9 and 1 minus X bar divided by L preferable. What should be the minimum L1 to achieve the 90% efficiency? So by simplifying, you will have this expression like this. So substituting U value 0 0.9, and if you are bringing the zero point 0.9 to this side and X bar over L preferable on the other side, so this side will become 0.1. Or in other word, L preferable will become 10 times of the X bar, and you will compute the L1. If this L preferable is coming out to be less than L1 that you have computed, then it means that this L1 will be final. If this L preferable is larger than previously computed L1, for example, this L1 you have computed is coming out to be 100, but L preferable is coming out to be 120. It means that you need to provide L1 equal to 120. Because if you provide the length of the weld L1 less than L preferable, joint efficiency will be less than 90%. So this check is only applied for tension member only. So sometimes we also check the L1 against the L preferable to provide sufficient joint efficiency. And after that, if you have designed the connection, if you know the length of the weld L1, L2, then you can check the block shear failure. Block shear failure is only applied once you know the connection detail. So you can also check the capacity against block shear by using these two formula. So block shear failure is the combination of shear yielding and tension rupture, and shear rupture plus tension rupture failure that we have already discussed in our chapter number 2, tension member design. So I believe that I don't need to explain because you already know how to check the block shear failure. If we are having an example, then I will repeat it again. Okay, now, if more than one member is meeting at a joint, for example, on this joint, so at this joint, five members they are meeting. This is the bottom chord, these are two diagonal chord, and this is the vertical chord member. Then if all members are discontinued, discontinued means that this member is not the same member, this is a separate member, this is separate and separate. Then you will design the connection L1 length of the weld separately for each member by sketching a separate free body diagram. You will sketch a free body diagram of this member only with the gusset plate. And if you want to design this connection for this member, then you will design the sketch the free body diagram of only this member with this gusset plate. So you will deal each member as a separate member which is connected at separate gusset plate. So Fu will be separately computed, which is either the factor force in each separate member or 50% capacity, whichever is larger. And weld value is constant for all five members. So bottom chord member, if both members they are separate, then we provide a splice plate at the bottom just to transfer the forces from one member to the other member also. So splicing is provided in the top chord or the bottom chord if adjoining member they are same. And also please note that center line of all the members they are meeting at this point. So we do not discontinue any member at this point. So any one member is extended beyond this point of intersection, and then we provide the gap. Because due to stress concentration, there may be heavy stresses in the plate. So this splice plate, if it is provided over here, it may be broken. So normally this distance is kept as a 4 millimeter from this joint. We extend the plate minimum as a 4 millimeter on drying, and then this gap is provided as a twice of this length. So I will repeat when I will explain the design of this drawing sheet, sketching of drawing sheet. So if so top or bottom chord member is discontinued. For example, this these are discontinued because we have not they are not continuing, they are separate members. Top chord member is discontinued at a joint. Splice plate should be used with the projecting leg of the member perpendicular to the result plate. So in that case, we need to provide this splice plate. So width of this splice plate will be equal to the width of this total joint, and the length may be computed to safely transfer the forces from one member to the other member. Thickness of this splice plate must be approximately equal to thickness of the member, and this type of the joint is called splice joint, and is done at some distance away from the point of a member to avoid the. So thickness of this splice plate is equal to thickness of this angle section or this channel section or any connecting member, and this splicing is beyond this point of intersection, and, and then we provide intersection because here all the forces their center line is meeting here. If we provide gap here, so there might be fail, and the plate may be taken as a 50% of lesser member force out of forces on the both sides. So this plate may be designed by considering the 50% plates which is transferred from one member to the other member. 50% of the forces which are transferred from one member to the other. So force transfer to splice plate may be taken as 50% of lesser member force out of forces on both sides. If in this member force is 80 kilonewton and in this member force is 100, then the force in this for which this splice plate is designed area is 50% of this lesser force, which will become 40 kilonewton. 50% of 80 kilonewton will be 40, and this will be designed at plate uh, thickness. But minimum thickness should be equal to the thickness of this angle section. Okay, now we are having this case. In this case, if top chord member or bottom chord member is continue mean that, for example, if in this member force is 100 and in this member force is 90, so instead of designing this lesser member force, we continue the same member on the other side. So it means that in that case, how we will design the connection for this combined member. Either you will design for this F1 force or F2 force. This design will be different. So sometimes top chord member and bottom chord member may be continued. In that case, how to design the welded connection or the riveted connection for this bottom chord. So first of all, I will show you the truss again. First of all, I will show you the truss that I have shown you earlier. Here you will see, and I guess here you will see that this member and this member is the same member. So these are not two separate members. A same member is continued over here. So in this case, for which force you need to design this connection, you need to determine. Here, I guess this member and this member are discontinued and they have used splice plate because the maximum length of the section which is available in the market is 4 meters. And if the combined length of these two members is less than 4 meters and the both are having same section, so instead of discontinuing any one member, we can provide a single member throughout this connection. or through the other panel. So this is the same member on the both sides. These are not separate. So how to design this member, the connection for this member? So this continuous member may be bottom chord or it may be top chord. Top chord member may be diagonal or it may be flat just like this just. So in that case, the member forces may be computed separately and procedure is given separately. Let me copy this equation. So in that case, you may have, for example, this bottom chord member for which you need to design the weld. So you need to design the weld connection, welded or riveted for this bottom chord. So bottom chord member one, on the one side of the member force may be F1 and other side may be F2. And F3 will be the force in this diagonal member and F4 will be the forces on the other diagonal member. And F5 may be the force in this vertical member. Sometimes you may have this vertical member or may not, or sometimes you may have only 4 member or sometimes 5 member like this. Okay, here you can assume that F1 is the force and F1 is the larger force out of these two members. And similarly, F3 is the larger force out of these two diagonal members. So F1, for example, it may be 100, it may be 90. F3 may be, for example, 70, and F4 may be 50. So you can give the name. Even you can give this as a F4 and this may be F3. Or you can just maybe memorize, can give any name, F1 or F2. So just for your understanding, I will recommend that the larger force should be F1 and the lesser force should be F2 or vice versa. If you want larger force F2 and smaller force F1, that may be the same. And similarly here, that F3 may be the larger force and F4 may be the lesser force in two diagonal members. These forces may be compressive, this may be tensile, and theta, you can call it theta 3 is the angle of force F3, and theta 4 is the angle of force 4 with reference to the longitudinal axis or this bottom chord member. In that case, actually AISC says that how you can compute the design force FU. So design force FU will be the lesser value out of these three cases now. So first case is the absolute value of F1 minus F2. Or I will explain what he want to write. So the first equation that I have written here, I will explain. Let me write the all these three cases be more easy to explain. now these equations are completed. I have contributed. One equated connection is lesser out of these three equations. So number one equation is absolute value of F1 minus F2. Absolute value means difference because we want the and for this horizontal forces and maybe tensile. So if F1 will be compressive, then F1 you need to substitute with negative sign. Then he says that the larger force out of these two can be replaced with their 50% capacity if it is more. So I'm considering that F1 is larger force than F2. Then if the 50% capacity 1, then F1 can be replaced by their it may either be in compression or tension. The member, if the member is the tension member or compression member. For example, if F1 member is the compression member, then F1 force or 50% capacity, whichever. So this is the first. Second equation is that in you will take the horizontal component of this force F3 cos minus 4 theta. F3 is larger than F4 and placed by its 50% capacity of F. This member is more 3. So this equation F3 cos theta minus F4 cos theta. If 50% capacity, so here this will be F4 cos theta. The 25% capacity of member. So again F1 minus F2, 1 F cos theta minus F or 25%, whichever is the larger, that will be FU. It can be replaced by so I'm repeating it again. In case of unloaded top, unloaded also further. If the no load is acting on this joint, because if the load is acting on the joint, then the is different. In case of unsupplied and unloaded top and bottom chord joint, just like in this figure, the top and bottom chord weld is designed for a difference of the forces on the two sided, which is the greater one. So number one case F1 absolute value greater of F1 or F2 may be replaced with 50% of member capacity for corresponding member. If 50 minus F4 cos theta 4. Again, if 50% capacity of the F3 is more than F3, then F3 will be replaced with this 50% capacity and 25% capacity of the larger member. So both members are the same. So 50% capacity. So out of these three, so whichever is the larger, that will be used as a formula. further is that in case of top chord member or bottom chord, if a load is also acting panel point, for example, you might have computed the panel load for your trusses. If top chord member is continuous and also it is subjected to force P, then this applied force, it will be serving as a shear force for this weld because it will in horizon in along perpendicular to this load direction because you are designing the weld for this axial forces. But now an external force is acting on this weld also. In that case, you need to compute the component of the force which is perpendicular or in the transversal direction. If top chord is flat, V is equal to P. If top chord is inclined, then this V force you need to compute that will be equal to the cos function of this P force. In that case, you need to modify the formula. In case of loaded and unsupplied joint, design is carried out as in step 20. If you have designed for these forces F1 and F2, you will design, but you will check again. But an additional check is performed. The required This is required because the weld should provide extra strength to transfer the perpendicular load or perpendicular shear force to the member. In that case, this P force V is will be equal to P cos theta. And you already know this P force, that is the panel load that you have already computed. Panel dead load and panel live load. You have already computed for your table of forces. So whatever is the panel load, that is the 1.2 time of the panel dead load plus 1.6 time of the panel live load. And the V force will be equal to V cos theta if top chord member is inclined. So in that case, you will compute the modified weld value. Modified weld value is computed as a FU, which is the larger out of these three, divided by length of the weld that you have already provided plus V force you have computed divided by length of the provided value. And then you will compute a modified weld value. If modified weld value is lesser than the weld value you have already computed, your design is okay. Otherwise, you will revise the length of the weld for this modified weld value. So if RW bar is less than RW, design is okay. If modified weld value is more than RW, you will recompute the length of the weld by this R modified. So increase the weld length, it means that you need to compute the length of the weld for this RW value. So just hold on for a couple of minutes. I need to pick a call, then I will continue. So in the meantime, please recall if you are having the any, you can ask me during this. Explaining that, so if there is any question so that I may write it again. So let me copy some equations from previous slide. So I would like to give you the final concept. So what is the concept is that for top chord or bottom chord member, uh, for which the panel points they are loaded, in that case, you need to compute the length of the weld by using this formula. So length of the weld will be equal to Fu and divided by Rw. And this this RW will be modified RW dash. So compute the length of the weld by this formula, RW modified. So I would preferably would write here. So compute. If RW prime is more than RW. So now we are going to solve one numerical. So that will be quite quick because that is a simple. Design a weld for a tension member as shown in the figure, and using E70 electrode. Thickness of the gutter plate is 10 mm and the factored force which is acting in this member is the 300 kilonewton. We can assume that this is any diagonal member of your truss, and this factored tensile force or that you can get from your table of forces, and we need to, this is the angle section, and the thickness of the gutter plate is 10 and we're supposed to use E70 electrode. You have already assumed that design this angle section, and for this angle section standard designation is L89 76 into 9.5. 89 is the larger leg, 76 is this shorter leg in outside the screen direction, and 9.5 is the thickness of angle section. So first of all, I told you that, just try to recall, we will decide the thickness of the weld. If we want to decide the thickness of the weld, so we need two thicknesses, TP1 and TP2. So TP1 is the thickness of thinner plate, which is 9.5 thickness of the angle section, and TP2 will be the thickness of our larger plate, which is the gutter plate, because we are connecting the gutter plate with the thickness of with thinner plate. I'm just trying to find out the pages, number of the page uh, from which we need to consult the table. Maybe that tables are on LRC manual. Last time where they were around maybe page number 75, not 75. Yes, page number 86. On page number 86, LRT manual. So I would like to recall this equation, which is yes. Because what I do, I always try to write the equation that we need to use for the design. So in this, we need to compute the length of the weld, and the length of the weld is equal to FU divided by weld value. And first target is, what is FU? I have already explained. FU is larger out of the factored tensile force or 50% capacity. So we will determine the 50% capacity of this member. This member is in tension. So no, we are using the welded connection. So no hole is punched. So tensile capacity of phi TTN value is equal to 0.95 into gross area into yield value. So for this angle section, L89 into 76 into 99.5, from section properties table, we can check the area. Area is 1480. Y value we have also taken from the LRFD manual. Y value for this angle section is 27.4 and D minus Y is 61.6, because D value is 89. 89 minus this Y, which is 27.4, you will have D minus Y, which is 61.6. So phi TTN capacity and in yielding criteria is phi Fy into gross area divided by 1000. So tensile capacity in yielding is 330 kilonewton. Now the capacity in rupture criteria is phi t, Fu. So U value is can be considered as a 1 and R value is also 1 because no hole is punched. So net area is equal to gross area. So U value is equal to 1 R. So we are assuming shear lag factor. So 1400 into 80. So the capacity in rupture criteria is 440. So the capacity is lesser out of these two. So 50% capacity is lesser value out of this yielding criteria and rupture criteria. So 50% capacity is half of 330. So 50% capacity is 166.5 and TU is 300. So Fu is larger out of 50% capacity and factored force against which the member is subjected. So factored force is more than half 50% capacity. So Fu is 300. Now TP1 is equal to 9.5 thickness of random section. TP2 is the thickness of the gusset plate because that is the larger thickness. So if you see the table number, uh, the table given on page number 86 on LRFD manual, minimum thickness of the weld for fillet weld. So TW minimum is 5 mm because if the TP1 is between 6 to 13 mm, so because our TP1 is more than 6 mm but less than 13 millimeters, so for this case TW minimum is 5. And for TW maximum, so if TP1 is more than 6 millimeter, TP1 is more than 6 millimeter, then TW maximum is TP1, that should be TP1 actually. TP1 minus 2. So this expression is also given on page number 86. So the maximum thickness of the weld may be 7.5. Minimum thickness of the weld will be 5. And we already know T optimum. Maximum of thickness of the weld, weld thickness 7.5, 5 and 8. So we will arrange these three values in ascending or descending order. The value is 7.5. So we will pick the middle value 7.5. And we will round to the nearest integer number. You can even round to the 7 mm. But here we have rounded to the upper side as 8 mm. So T adopted is 8 mm. Then you will determine the weld value, which is either based on net weld strength value, 0.707 factor to convert the thickness of the weld to the effective TE, and 1 is the length of the weld, we are assuming as a 1, and zero point 0.6 is the factor to convert the normal strength to the shear strength. So ultimate value of E70 electrode is 495. And these value you can pick maybe at the start of LRFD manual. Maybe on page number, I'm checking the page. No, they are not given on page number. Page number 3. They are given the properties of the board, but not for the weld. But anyhow, the ultimate strength of E70 electrode is 495. You need to remember, or you can divide the 70 by 0.145. So this is the weld value or the strength of a weld whose thickness is equal to 8 mm and the length is equal to 1 millimeter. And then second weld value you will determine based upon the weld strength, which is 0.75, is the strength reduction factor. 0.6 into FU. 0.6 is to convert the ultimate strength of the base metal, which is 836 steel, normal strength to shear strength, and this is TP1 because TP1 thinner plate may break 9.51 into length of the weld or thickness of the plate equal to 1. So we are having one weld value based upon the weld strength and one weld value based upon base metal. So the lesser value out of these two will be the weld value, which is 1.26. So weld value is the force taken by a unit weld in kilonewton, which is either based upon the net weld or base metal. So weld value is coming out to be 1.26. Then length of the weld is determined as a FU divided by weld value by using this formula. So this formula we are using to determine the total length of the weld. So this formula we use. So FU is 300 divided by weld value. So total length of the weld will be 238. First, we will not provide L3 and we are computing L2. So L2 will be equal to length of the weld into Y over D ratio. We have already derived this expression. So length of the weld is 238. Y value for our angle section is 27.4 that we have taken from section properties table, and D value is 89, largest length. So L2 is coming out to be 73. Round to the multiple of 5 millimeters on upper side, that will be 75. So L1, you don't need to compute by the actual expression, but you can compute L1 by subtracting L2 from the total length of weld. So that will be 165. So for example, if in the given in the examination or in the statement that also check the weld for minimum efficiency factor 0.8, then this factor you already know that I have explained. So you can compute L preferable. So L preferable you can compute by this expression. Maybe I will like to write here. So you can write U is equal to 1 minus X bar value over L preferable. L1 preferable, okay? You can write this. This is the L1 length required to achieve the efficiency. So what you can do, you can substitute the U value 0.85, X bar value you can take from the section properties table, which is 21.1. So you can compute L1 preferable. If L1 preferable is more than L1, then you will use the L preferable. If L1 preferable is less than L1, so you will use L1. So L preferable is computed, which is coming out to be 145. So this is the minimum length L1 required to achieve the efficiency 0.85. So that is 145. But we have already computed L1, which is more than 145. So we will use the L1 as a 165. We know that LW minimum is 4 times of thickness of the weld, and LW maximum is 30 times of thickness of weld. 4 times, or in some cases there are two values, or 38. So that value will be 38, should be used. not only 4 times thickness of the weld, 4 times or thickness of the weld, whichever is larger. So this is maybe 38, we can down to the 40. And LW maximum is 30 times of thickness of the weld. Thickness of the weld is 8, so 30 times of thickness of weld is 240. So both L1 and L2, because L1 value you have computed, let's make it 38. Because L1 is equal to 165 and L2 is equal to 75. So here see, we have computed L2 as a 75 and L1 as a 165. So both L1 and L2, they are more than LW minimum and they are less than LW maximum. So we may provide. So this is a single angle. So we have to show L1 on the thickness side and L2 over here. And we have to show the proper designation. Okay, here you will see that the symbol will be written this, actually this triangle should be on the opposite side. Let me flip it. So after flipping and also flip to the, yes, here. Why I have flipped here? Because symbol is toward the arrow side. So we are just showing that we need to provide the weld thickness 8 and the length of the weld should be 165, and this arrow is on the upward, so thickness should also be upward. And here the length of the weld should be 75 and thickness 8, and the both arrow and the weld dimension should be on the arrow side. So this is the proper designation we have to show. And we can also check the block shear strength. So next time we will discuss some more advanced cases where we are having the limitation of L1 and L2. They may be more than LW1 maximum, and uh, how to control the L1 if it is coming out to be more than maximum length of the weld. So in the meantime, if you are having any question, you can ask me. Anybody is having the question? So the student who are present or the online, they can raise the hand option. Use the raise hand option. So I will check. So I will wait for the student whose hand is not raised. Okay, CR, please note down the roll number of two students. CR, can you hear me? CR.
Yes, sir. Yes, sir.
One is Amish Bashir and
सर ये
Umar.
प्रेजेंट है आई थिंक वो मैसेज मुझे आ रहा था शायद
अच्छा,
प्रॉब्लम आ
और
रहा
ये
है वो
उमर।
हैंड रेज हो रहा है लेकिन वो फिर
ठीक है, ठीक है, ठीक है, चलें, ठीक हो गया। तो attendance is, so Umar Malik, he came late. Where is Hasib Bhatt? Okay, can you hear me? Hasib Bhatt, क्या नाम है इसका? हसन भट्ट। Yep, Sia.
सर HB जो है वो हसन भट्ट है.
हाँ जी, HB. Hassan Bhatt sahab, can you hear me? If you can hear me, respond me. You can remove the raising hand option. Where you was in the first lecture?
सर उस टाइम मैं दरअसल वॉशरूम में गया हुआ था जब आप प्रेजेंट बोल रहे थे. वो मुझे दोस्त ने बताया कि सर बोलते रहे, लेकिन मैं उस टाइम गया हुआ.
मैं आपको ठीक है, मैंने आपको it is not the first time with you. It is not the first time. I checked you many times, maybe 4-5 times. So it always happens. Okay, no issue. So I will conclude the lecture. Inshallah, I will see you in the next class. Till then, Allah Hafiz. So Sia, please send me your class schedule so that we can reschedule the design
Okay,
class for
sir.
the next week. Okay,
Okay,
thank you
sir.
very much. Allah Hafiz.
Allah Hafiz.